All right, let's dive in. Today, we are tackling a subject that, well, it sounds like pure science fiction, but it's actually one of the most profound and complex puzzles humanity has ever stumbled upon. And that's the challenge of artificial superintelligence. You know, this isn't just about building slightly smarter computers. This is about a fundamental shift in the world as we know it. So let's try to deconstruct this thing piece by piece.
So, what are we even talking about here, really? Well, this definition from the philosopher Nick Bostrom is absolutely key. When we say superintelligence, we are not talking about an AI that's just a little better at playing chess or spotting cats in pictures. No. We are talking about an entity that is to us what we are to a chimpanzee. Think about that gap. It would be an entirely new kind of mind, operating on a level we can barely even begin to imagine.
And that idea leads directly to a concept that researchers call the intelligence explosion. Just imagine an AI that gets smart enough to start improving its own code. Well, that new version is now even smarter, right? So it can improve itself again, but this time more effectively. You see where this is going. It's a recursive runaway feedback loop, creating technological growth so fast, so explosive, it could leave human comprehension and control completely in the dust.
Now, I know what you might be thinking. Okay, but haven't we faced huge technological risks before? What about the nuclear arms race? And that's a totally natural comparison to make. But the AI race, it's a different beast entirely. And in some really crucial ways, it's far, far more dangerous.
See, with nuclear weapons, you had this strange kind of stability called mutually assured destruction. Nobody wanted to use them. But the AI race is what you'd call a winner-take-all game. The very first group to build a true superintelligence could gain an absolute insurmountable advantage over everyone else on Earth. And that creates this insane pressure to rush, to cut corners on safety. Which means the biggest danger might not even be a malicious AI, but an accidental catastrophe that happens during the frantic race to build it in the first place.
And this brings us to the next massive hurdle. If the future with AI is so radically different and the stakes are literally existential, how on earth are we supposed to prepare for it? How do you forecast something that is, by its very definition, completely unforeseeable?
The reason this is so tough is that all our usual mental tools for thinking about the future just break. We love simple stories. We love drawing a trend line on a graph and just extending it forward. But those methods are totally useless when you're talking about a technology that could fundamentally rewrite the rules of reality itself.
You know, psychology research shows we are hardwired with this bias for simple, easy-to-imagine scenarios. We latch on to what we think is the most likely story, and then we get way too confident in it. But with AI, the reality isn't one story. It's a huge, sprawling space of possibilities. And if we bet everything on that one simple story, we are almost guaranteed to be blindsided by everything else.
So we need a much more disciplined approach. Instead of telling ourselves a single bedtime story about the future, we need to break the problem down. Think about things like computing power or global stability as separate pieces. Then, instead of just saying something is likely, we assign it actual probabilities. And finally, we combine a whole range of expert views. This helps us move away from a single, probably wrong guess and toward a much richer, more honest map of what might actually happen.
Okay, so let's say we somehow manage the geopolitical race, and we get better at predicting the future. We still run smack into what might just be the hardest problem of all, the value problem. How do we make sure that this super intelligent thing we're building is actually, a good thing? That it's aligned with what we care about? I mean, the entire field of machine ethics right now is built for a world with pretty simple robots, almost always operating under direct human supervision. But all of those foundational assumptions, everything we take for granted, it all just completely shatters when you're designing an entity that will be astronomically more intelligent and more powerful than its creators. It's dangerously naive. Just look at how our assumptions crumble. We assume we control the AI's goals, but what if it decides to change them? We assume we're always more powerful. What happens when we aren't? We assume we can test it safely, but it will face situations we can't even imagine, where a mistake could be catastrophic. Every single one of these broken assumptions is a monumental safety challenge that, right now,
we have basically no idea how to solve.
And if all of that wasn't mind-bending enough, there is one more layer to this puzzle, a problem that goes all the way down to the very foundations of mathematics and decision theory. It turns out there's a weird paradox right at the heart of telling an AI what we want it to do.
To get this, we just need to quickly understand something called a utility function. It's not as scary as it sounds. Basically, think of it as the AI's scorecard. It's a bit of math that spells out the AI's goals. For any possible future, the utility function gives it a score. The AI's job is simply to take actions that get the highest expected score. Pretty straightforward, right?
Well, hold on, because here's where it gets really weird. What if the goal we give it is unbounded? Something like make as many paperclips as you possibly can, or create the maximum amount of happiness in the universe. These goals don't have a ceiling. There's no 100%. You can always, in theory, add one more paperclip or one more unit of happiness.
And this is where the research from Peter DeBlanc is so important. He proved mathematically that for a universal AI, that's one that can think about all the possible ways the universe might work. If you give it one of these unbounded goals, the expected score for any action it could take becomes undefined.
So what does that mean in plain English? It means the AI literally cannot calculate what to do. The math completely breaks. It gets paralyzed, unable to decide between a reasonable, achievable plan and some crazy 1 in a trillion shot at an infinite payoff. This isn't just a philosophical problem, it's a fundamental mathematical paradox at the absolute core of its mission.
So let's just quickly recap the journey we've been on. We've peeled back 4 distinct but tangled layers of this AI challenge. We started with a geopolitical arms race unlike any other in history. Then we hit a prediction problem that our brains aren't built for. Under that, an ethical problem where all our safety assumptions go out the window. And finally, at the very bottom, a deep mathematical paradox that makes it hard to even tell the AI what we want.
Which leaves us staring at this final massive question. If we can't reliably predict its arrival, if we have no clue how to control it, and if we can't even give it a goal in a way that's mathematically sound, what do we do now? This really reframes the whole AI problem, doesn't it? It's not some simple engineering race to a finish line. It might just be the greatest test of foresight, wisdom, and humility that our species has ever faced.